All right, in this video, I want to talk to you about number of solutions. And so we're going to generalize what we find on Khan Academy in Algebra 1 in the second unit, which is solving equations and inequalities. In that unit, you find two problem sets on number of solutions to an equation. And you might have an equation like negative 17x plus 2 equals negative 17x plus 3, like this. And so in order to solve that, in the previous video we talked about how you can set these things, they are set equal to each other, so you can solve for x and see what happens. If we did that, we would want to distribute negative 17, and we'd have negative 17x minus 17 times 3 is minus 51. And then on this side, we didn't change anything. Now, we notice that we have the same number of x's on both sides of the equation, so when I subtract negative 17x, when I add that, 17x, it disappears, and I'm left with 2 equals negative 51, which isn't true. So because we end up with an equation that's false, and we have no variable, it means we could have picked any number for x, and those x's would have canceled, and we'd be left with this false statement. We figured out that that means that there is no number that we can put in for x that makes this true, which means there's no solution. Now, in this video, I want to generalize what we just did so that we can maybe look at these things a little more structurally and not have to step through a lot of the specific work each time, okay? That's one of the powerful things about mathematics, is taking things that are case specific, like this particular equation, and solving for that one case. If we generalize it, then we have a powerful tool that we can apply to any particular case. So let's assume we have an equation in this form where there are no parentheses. We've got x's on both sides of the equation. Let's generalize it and say that this constant could be any constant. We'll call that a. So a times x plus another constant, we'll call that one c. And then this constant, in this particular case, it was the same one as that, but if we're generalizing, we are saying it could be whatever constant we wanted, so let's pick b. So b times x. And then here's another constant, and we'll call it d. Okay, so here's a general equation that has a particular case where a is negative 17 and b is also negative 17. That's okay. The same number can have more than one name. Just like you and I can have a different name, right? Not you and I, but I can have a different name, and it's still my name. I happen to have 4 names. My name is Eric, and then my last name is Robinson. I've got some middle names in there too, but I could go by any of those names because each one of them is my name. In the same way, negative 17 could be called A, and it could be called B. Okay. C could be 2, D could be negative 51. It could have been flip-flopped. It doesn't matter. We're just saying that these capital letters are standing in the place of some constant. All right. So in that case, we figured out that if A and B were equal to each other, like in that particular case, if A equals B, then when we subtract bx from both sides, it's like subtracting ax from both sides. They cancel out, right? So if A equals B, you are left with C equaling D. And we'll put a plus here, by the way. Let me fix that. We want this to be in the form where we're adding. So D could be a negative number, like D is negative 51, would have been what we had there. Okay, so if A equals B, then the x's cancel. So if A equals B, then the x's cancel, which leaves you with the equation that C equals D. Now, if C equals D, and that's true, if C really is the same constant as D, then that means no matter what x value you put into this equation, the result is a true equation. That means that any number could be a solution. That means there are an infinite number of solutions. So let me write it this way. If A equals B and C equals D, then there are infinitely many solutions. Okay? So if A and B are the same thing, then we can subtract those x's from these x's, and there will be nothing left but the C equaling the D. And if it's true that C equals D, then we have an infinite number of solutions. If A equals B and C does not equal D, well, that means we ended up with the x's canceling, and we ended up with an equation that's false, because if you claim that C equals D when it doesn't, then there are no solutions. Now, the last case we could have is if A does not equal B. If A doesn't equal B, then when we subtract this number of x's from that number of x's, we will still have x's on one side of the equation. And we can subtract C from both sides, and we'd have some constant, D minus C, whatever that is. That would be equal to the number of x's that are left. So you could solve for x, and in other words, there would be one solution for x. Exactly one, only one solution. And if we wanted to know what that solution was, we could do a little algebra on this. So let's do that. Let's say AX plus C equals BX plus D. Now we want to solve for x, so we will subtract BX's and we will subtract C from both sides. And then we can use the distributive property to factor out an x. So x times A minus B, that's A times x, minus B times x, okay? And then that's still equal to D minus C. If I want x alone, I need to undo the multiplication here, so I can divide by A minus B. That'll give me x equals D minus C over A minus B. So no matter what equation you have, if it's in that form, you could know what the one solution is here. Also, so this is one solution, and that solution is x equals D minus C over A minus B. So we can know the solution. Also, if you go back up to these, look at what happens when A equals B. Look at what happens with the supposed one solution you would have. That would make the denominator 0. If A equals B, then A minus B is 0, and you'd have a fraction with a 0 for the denominator. That would mean that x is undefined. X is undefined as a single number, right? So there are infinitely many solutions. So X could be any number, but there is not one solution, so X is undefined. That is, it's not defined as definitively being this one number, okay? X would also be undefined here, because again, A equals B means the denominator is 0. Not only is there not a single number that X can be, but there's no number that X can be in this case. And we're done.